The Model Context Protocol, MCP, is an open standard that enables AI models to connect with various data sources and tools. The Model Context Protocol, MCP, is an open standard that enables AI models to connect with various data sources and tools. It's often described as a USB-C for AI, a universal interface for AI applications to plug into different systems. This presentation will cover what MCP is, why it's important, how it works, key benefits, adoption examples, and future impact. We'll see how MCP aims to overcome AI's data silos and enable real-time secure tool integration. What is MCP? MCP is a universal protocol for AI connectivity. Just as USB-C standardized device connections, MCP standardizes how AI models interface with external resources. It defines a common language for AI clients and data tool servers to communicate. Instead of custom integrations for each app or service, any AI agent supporting MCP can connect to any MCP-enabled tool. In short, MCP provides a single, open hub linking AI models to files, databases, APIs, and more, regardless of vendor or platform, much like one universal plug for all AI needs. Why is MCP important? Breaks data isolation. Today's AI assistants are often trapped in silos, limited to their training data and unable to fetch fresh or proprietary information. Each new data source currently requires a bespoke integration, hindering scalability. MCP changes this by allowing real-time data access. An AI agent can retrieve live information on demand via MCP instead of relying on static knowledge. This means an AI with MCP isn't stuck with outdated info. It can securely query your latest files, databases, or services when needed. By standardizing integration, MCP eliminates one-off connectors and opens the flow of current, relevant data to AI in a consistent, scalable way. How does MCP work? MCP follows a client-server architecture. MCP host, client, the AI application or assistant that needs data, e.g. an IDE plugin or chatbot, acts as the client initiating requests. MCP server, a lightweight adapter program that provides access to a specific data source or service. Each server exposes certain capabilities via MCP. Handshake. When a client connects to a server, they exchange an initialized message to agree on supported features and protocol version. Communication uses a standard format, JSON RPC 2.0 over channels like HTTP or StatIO for requests and responses. Data sources. The MCP server interfaces with actual resources, e.g. your local files, databases, or an external API, and returns the needed data or actions to the client in real time. Multiple servers. One host can connect to many servers at once, enabling a single AI client to tap into numerous tools. MCP essentially creates a hub-and-spoke model. The AI client speaks the same MCP language to any number of tool-specific servers. Key features. Standardization. MCP transforms an MN integration problem into M plus N. AI developers only need to support MCP, and they gain access to all MCP-compatible tools, fostering a unified ecosystem instead of fragmented custom APIs. Real-time access. Tools can be invoked at runtime, not just design time. An AI app can dynamically add new MCP servers on the fly, allowing users to plug in new functionality, e.g. a calendar or database, while the AI is running. This means AI assistants always have up-to-date info and services at their fingertips. Security and control. MCP is designed for secure, two-way connections within your infrastructure. Data stays under controlled access, e.g., an enterprise can run MCP servers behind a firewall, exposing only what's necessary. MCP's standardized approach also encourages best practices for authentication and permissioning. Scalability and flexibility. Because integrations are standardized, AI providers can switch out or add data sources without major rework. You can swap the underlying LLM or tool vendor and still use MCP. This interoperability future-proofs your AI stack and encourages a growing library of MCP servers. Open source ecosystem. MCP is openly released with SDKs and reference implementations. The community is actively building connectors for popular apps, Google Drive, Slack, GitHub, databases, etc., accelerating the growth of available integrations. Developers and organizations can contribute and benefit from shared MCP tools rather than reinventing integrations. MCP is gaining traction in the AI and developer community. Early adopters include companies like Block and Apollo, who integrated MCP into their systems, and several developer tool firms such as Zed, Replit, Codium, and SourceGraph. These integrations enable AI assistants to retrieve context from coding repositories, chats, or documents to enhance their responses. Example: in a code editor, an AI coding assistant using MCP can query a project's GitHub repo or documentation in real time, leading to more relevant suggestions and fewer hallucinations. Tools like Claude Desktop have built-in MCP support, so users can plug in servers for things like a local file system or Jira tickets. This showcases MCP's flexibility, from customer support bots pulling knowledge base articles to personal assistants managing your calendar. The protocol is being used to connect AI seamlessly with real-world data and services. Why MCP is a game changer. MCP bridges the gap between isolated AI and the real world. By solving the data silo problem, it unlocks true agentic behavior, AI that can act on live information. Developers no longer need to write one-off plugins for each app. Adding a new capability is as simple as running or installing an MCP server for it. This dramatically lowers integration effort and accelerates innovation. Furthermore, MCP lets end users augment AI apps with new tools at will. Because this can happen at runtime, the user, not the developer, can add arbitrary functionality to the LLM application. In concept, an AI assistant becomes more like a web browser, able to navigate and interact with many services through a common protocol. As the MCP ecosystem grows, any AI equipped with it can maintain context across diverse platforms and perform multi-step workflows that were previously impossible without extensive custom coding. In summary, MCP is poised to fundamentally enhance AI's usefulness by making integration scalable, flexible, and user-driven. Conclusion: MCP represents a transformative shift in how AI systems interact with the world. By standardizing connectivity, it empowers AI to remain informed and useful across domains, maintaining context as it moves between tools. We can expect a future where your AI assistant seamlessly taps into whatever resource you need, whether it's your personal notes, enterprise databases, or internet services, all through the MCP framework. This open protocol is driving a collaborative ecosystem. As more developers contribute MCP servers and clients, the capabilities of all AI assistants grow. In closing, MCP is not just a tool integration layer, it's a foundation for the next generation of interconnected, context-aware AI. The journey is just beginning, and we're excited to see how MCP will shape the future of AI applications. Thank you for your time. Questions or discussion? Feel free to ask about how MCP might apply to your use case or how to get started. Join the community of developers and organizations exploring MCP. Together, we're opening new frontiers for what AI assistants can do.